All right, we are going to take a look at another possible game that could be created using Code Sculptor and Python, and it is a sample of the snake game where you have a little snake, you eat an apple and grow longer and longer, and if you end up hitting yourself, you die, and if you eat the apple, you grow. And I'm going to take through just the basics. The whole game will not be finished, but it's going to be basically from beginning to, 3/4 of the way through in one take of looking at how to build this game. It's really quite simple in its concepts, and there's just a couple neat little twists that it does that causes it to work the way it does. An example right off the bat, just so you can see it, I'm just going to use circles, and I can move around on the screen. And when I eat, I grow a little bit bigger. And so you can see how that works, and you can see how it follows the way I move around. And there's like, you can see I got a bug. Why all of a sudden it decides not to work on the collision detection. So the first time I played it, it worked beautifully, and then I must have made one little change that threw it away. But if I do eat myself, like I go back on myself, I just die, and I got my life. So that's what we're looking at. We're gonna start from, nothing basically, and so get yourself a blank code sculptor with just these things in it. In order for the sake of time, I'm going to move kind of fast and assume that you, the viewer, can pause and see the code or can rewind and get an explanation if you don't understand it. So we're just going to kind of go through it and see how we do. I don't promise to not make silly mistakes, though, because that's what I do. We're going to need some random numbers later on, so we'll go ahead and import that. I like to set up some constants at the beginning, such as width and height. And hey, why not some speed? And there's one more, but we'll wait till it makes sense to put it in. I'm going to change my frame down here at the bottom. So watch that to width and height. I am going to add the keyboard handler. Strangely enough, I'm only going to add key down. I'm not going to add key up because of something that we're going to try to do with it. That's a little bit different. So that's the basic stuff down there. We'll add one more thing down there when we get to it. Then we have some variables. Now, the most interesting variable in here is our snake. Our snake is a list, if you think about it. When I played my game, which yes, I do have all the code right here, this is the 0th position of the list. This is position 1, this is position 2, and as we eat the apples, we just add. So every circle is like an item in the list, and we just draw that list to the screen. So that's how the snake works. Don't peek at that code yet, though. And then, there's two things I can see us wanting right away. First of all, what's our starting length of our snake? I think it makes sense to start fairly small, but you could change this once you get it working, and it'll be pretty funny. And, oh man, it'd be funny to do some big number. Okay. And then we have snake, and snake is going to equal an array, so it's like that. And like I said, each item in the snake is, each circle is like a part of that list. So we're going to set up the initial values of it. So because I'm using length, I'm going to just make a shortened version of it, L, whenever I go through a loop, right? But if you've watched other videos on how I do these things, it's not that different. So we want to go from 0 to which is our first head, and then however many we have. And we're going to do a snake append, and we are going to append. So what is it that we're going to add to this list? That's the big question. And what we want to do is we're going to make, like we have in other things, we want to make basically a X and Y coordinate, right? So like every circle that represents our snake is going to have a position on the screen, and it's going to have an X position, it's going to have a Y position. So the big question is, basically the big question is, what is our starting values going to be for that snake? So, oops, yeah, right. So our first value, for instance, might be width divided by 2 and height divided by 2. Wow. So that it puts the first dot of the snake right in the middle. But then it gets a little funny because we want to be able to define each dot next to the previous dot, right? So if I do this, it'll do all the positions will be exactly the same. But every single time we draw one, it's going to be, I should just keep this on the screen, I suppose. It's going to be a little bit further away. Right? So I'm going to refer, even though it's a circle, I'm going to refer to each of these as a block. And if you think of this as like these blocks that are following each other. So one of the things that we want to do is we want to define how big we want those blocks. And what we're going to do is we're going to make it the way I did it, I defined mine as 20 pixels. But because that's a circle, we are also going to have a radius. And our radius is going to always be block divided by 2. So if we ever need to figure out the radius, we'll have it set up already. So the block is kind of like the whole square, and the radius, of course, is half of that. It's like this is almost like the diameter, and this is the radius. So then later on, if you say, hey, I want a bigger snake, you can change it this way, and you don't have to go through and change the radius. It'll just automatically happen, of course. So, so why do we have to do that? Well, because we have to basically take the width here. Height is fine for our starting position, but our width, we want to subtract the block so that each one moves over a little bit, but not just the block. We want to subtract the block times the position of the item. So the first one, when we do our for loop, L, this is an L, not a 1. The first one is going to be block 20 times 0, which is 0, so it's not going to subtract any. That's going to be block times 1, which is 20. So it's going to take this, it's going to subtract 20. So it's going to move it 20 over. And then the next one 20 over, the next one 20 over. So that's what's going to get us our starting values. So now our snake is created. And if we change this, that's fine. The math will work and make it longer and longer snake. You may want to add in some other values, such as lives. And there'll be some other ones that we think of. And we'll come running back up here and put them in there. So, two things, well, no, maybe three things that we want to do. We want to create our key handler, and we want to, of course, draw the circle on the screen, and then we want to move the circle on the screen. So those are our first things. And of course, the key handler is part of the movement. So let's do that one real quick, because it's really quite easy. The thing that makes Snake a unique game, the first twist, is the fact that once I start moving, I did give it rest here, but once I start moving, I cannot stop moving. The only way I can stop moving is by dying and going back to the beginning. So this one's funny, because once I set a direction, that direction's just going to keep on going, right? Oh, there we go again with the, whoa. See, sometimes you can get it. You have to be really right on, and that's where the bug. Whoa, I was right on that time. It almost seems like once I get this big, I can't get any bigger, which doesn't make sense. All right, but you can see how it keeps moving, right? So that's unlike other things, which is why we're not going to have the key down or the key up, because it's kind of like once I press the key, I am stuck moving in that direction. So I'm going to use the A and the D and the W and the S keys to do this. So um, you could use the arrow keys if you want to. I'm just not a fan of where the arrow keys are on my laptop. We use A, and then so we're going to make a new variable. And when somebody presses the A key, that means that they want to move left. So we're just going to use a string, and this is going to help us out with a bunch of stuff. So you can immediately just copy that because everything we're going to do is based on that, and we're going to change them to elifs. So if they press the D, if they press the S, if they press the W, all of these are elifs. And then what direction do those represent? So the D key represents going right, the S key represents going down, and the W key represents going up. Now, whenever we do this in Code Sculptor, we have to think to ourselves, did we change a variable? We changed a variable, and we never created that variable, so let's do that. We're going to have the direction, and up here we're going to have the direction, and we're going to do something funny at the beginning, is like we don't want to make it one of those to start, so we're going to make up stop. That's the nice thing about using strings. You can just program them to say whatever you want. I could imagine there's a more mathematical way to call this, like 0 and these different numbers, and then use some math. This is easy enough. It's fun. We'll do it. Okay, so that's key down. Hey, maybe we should draw our circle. Like, it's kind of funny. Like, okay, so what does direction do? We don't know yet. Direction's going to do something. But real quick, we'll draw our snake because we can get him started here. Like, we've created him, but he's not showing up anywhere. And this is really easy. We just want to run through our snake, our list. That's a snake. And we're just going to draw, if you remember how to draw a circle. And again, you can, on your own then, pretty easily change this. I know drawing images in Code Sculptor is a little bit more complicated, but you could pretty easily change the idea of what we're doing to any other shape or an actual graphic. So, where do we draw it? Well, we draw it at position snake L. So the first position, the second position, third position, which is created up here. Every circle needs a certain radius, and we define that already, so we can just say radius. Every circle needs a border. I'm just going to use one. And what color do we want the circle to, or the snake to be? So, like, just to say, for instance, we wanted it yellow. But I was thinking when I did this, I want to be able to see which snake, where my head is. And you could, of course, put in different graphics. And then you could use an if statement and say if you're looking at snake 0, that's the head, and you'd put in a special graphic. But I am going to just do it a different way. I'm going to make a variable called color. And then in this loop, I want to like check and see which one I'm currently on. So I'm going to say if L is 0, then color is going to be red. And if it's anything else, color is going to be yellow. And then it's going to draw it. And because we're at a stop position, and we've set up the initial values there, we can immediately see if this is going to work. There we go. Red one, yellow one, yellow one. Change our length to 30. Press play. And of course it goes off the screen. Big old snake. Let's not start at 30. All right, so there it is. Again, you can make some changes for, you could say if L equals 0, then draw image something, otherwise draw this other image something. This is the position of it, so it's really quite easy. If you want to do that, it's still nice to have the radius for the collisions later on, so you can still use that. So it's no problem. So finally then we want to move. Now again, in other videos I've done, I come down here and in the draw I say move and then we create a move function. So that's what we're going to do again for now, because there may be a change in a little while. This is the only mathematically tricky thing in the code that we're doing is, how do we move it? And the reason it's tricky is because when I move up, you see, like, everything follows the head. When the head moves, the other ones move too, but not right away, right? Like, it turns. And so it's got this delay. Oh, goodness gracious. I had this working so good before. We'll probably do a better job of it. It's weird that certain ones don't work. But you see how the tail follows the head, right? It makes like a square, and then you can go like that. So that's the only trick to this is how that moves. So yeah, there it all is, but you don't want to peek yet, right? So let me explain what we're doing one at a time. Well, of course, we're going to have some global variables. So this is put global for right now. We'll come back to it. Now, the truth is, since I've only done this once, I'm kind of spaced out. Well, here's the easy part. This is where we actually move it. So if that direction that we have here, stop, if that direction is right, then what we're going to do is right here, what we're going to do is just worry about moving the head, which maybe sounds funny. So we're going to say that the snake at position 0, and 0 is its x value. So that's the head's x value is what we're saying here. I'm going to say that that is going to be plus equals, to the right speed. So whatever the speed here is, that is also going to be that one. And you can actually just do this for all of them. If we're going left, then the snake's head is going to be minus equals speed. And then please copy and paste so you don't have to type it all over again. But now the snake's y value, so the head is still position 0, but the y value is 1. And then that's going to equal, well, it's going to up is minus equals speed, so the y value will change up. And don't put just an else because the directions might equal, such as stop, something besides these 4. And later on you may even want to create, I don't know, some special actions or something. So we'll just do it that way. So what we're going to do is the snake's position is going to change, well, the head's position is going to change, and then down here it will draw that new position. So if I played it now, oh yeah, global, that's not going to do anything, is it? Well, I don't think you have to declare lists, because lists are like automatically global, but I kind of like to because it reminds me that I'm using it. Like this is kind of like a list, so when I look at my definition later of my function, I can right away say what variables is it that I'm using in this function. So I'm still going to put this, though I think it works without it. Okay, so we only told the head to move, so when I go down, I can now move the head around. Ah, but my body doesn't follow me. I'm a decapitated redhead snake. So yes, that's why am I continuing to do that. But did you see how it moved? It waited, keeps going in one direction, and it moves rather fast. You might say, whoa, 10 is too fast. And that's because of one thing that we're going to do in a little bit. But the question is, how does the body follow? Um, and, well, let's see. I'm going to try to draw this out in Keynote, like live, instead of having something already created. So if I say, okay, here's, my snake. Hey, you're red. And then I was to do another shape and put it behind it and make it yellow. And let's just do 3 of them for simplicity's sake. And this is, of course, position 0, and this is position 1, and this is position 2. And this snake head here, 0, is got an x and a y value, right? So its x and its y value that it starts out with at 400, 300. It's about to move. So it's going to go like whoop over here, and this is going to become something like 420, 300, and it's going to move over here. I mean, the first move would be 410, so well, let's just say 410, right? Like it moves 10, so it moves 10 over. We need this one to get to here. In other words, we need this one to get the old value that the previous one had. So the whatever was in 0, it's got to shift over and become number 1. And then whatever was in 1 has got to shift over and become number 2. And then even if we moved up, this one would then shift to this position, and then it would next time go up to this position, right? So each one can follow along. And then, of course, once that happens very fast, you get things like that going on. And then, oh, we're going to go this way. And so now they all shift in that direction. And that's what we're going to do. So it's all a matter of taking the value that's in here and transferring it to this one, and then transferring it to this one, and so on and so forth. So we have, what we want to do is we basically don't want to do this at the beginning. At the beginning, when I first play my game, it's like, no, it's good. Well, of course, it's not going to work now. I just work, yeah. You're like, no, it's good. It looks right. And so what we're going to do is we're going to say if direction does not equal stop. So we're only going to do these things if it's not, if we didn't put this in there, it messes everything up like really quickly. Because it would just all immediately move on top of each other even though the head hasn't started moving yet. And then we're going to do a for loop. And as I thought about this for loop, I thought to myself, even though I drew it for you this way, where this one moves, then this one moves, then this one moves, really, if you went in that direction, you would actually start overriding values and then forgetting what the next one was. Like if 1 became what it was in 0, and then when 2 wants to copy 1, well, where did 1 go? It already has disappeared because it's already moved on here. And then this is like, where do I go? So we actually want to go backwards. We actually want to take, like 2 wants to grab number 1 and move this way. And then 1 can still see 0 in front of it. And so then 1 is going to like move over here to 0. And then 0 is going to move, forward. And that's what we already did. That's why we're putting this section of it before this section of it, because this is moving the head after we've moved the other ones. So all that being said, we want to say for L in range, and so here, if you know your for loops, we want to go backwards. We actually want to start at length, but we have to start at length minus 1, because the length is always 1 bigger than the actual length of it. And we want to count until 0, and we want to go in the -1 direction. So that'll count backwards, and then we can just say that we want snake L, like the one that we're currently looking at. We start at snake 2, for instance, and we want its values to equal what is in snake L minus 1. So it's just going to say, oh, take snake 2 and copy it into snake L minus 1, copy what was in snake 1, copy it over to 2. Go back through it again. Now we're at L equaling 1. So take a look at what's in snake 1 and make it equal to what's in snake 0. Then we end the loop because we say go until 0, and then here we move 0, right? So we've just moved 2, then 1, and then 0 for this. And you think, well, that's all it is, but uh-oh, it's not all it is. See, that's what happens if you don't do it right. They all bunch up together. You saw that it started right, and then it stopped. So let's take a peek at what I did different. Oh, look at that. That's right. I found out it's better to copy each of them individually. In other words, I copied the x value and then I copied the y value. Because lists work kind of funny. So all we have to do is add a 0 right there and a 0 right here. And then snake L position 1 equals snake. Because you know what? If you watch what I was doing, it was working until I moved up and then it stopped working. So this will get it to work on both values at the same time. So now now see how they moved closer together? It's like, okay, it worked, but they kind of went a little too close. They didn't keep their distance. So, so why is that? Like, if you just became equal to what it used to be. And so, again, I go to what I did before. And you can see, like, here's what I was working on in my finished product. It didn't do it there. It didn't do it there. But if you think about it, what just happened was, what's going on there? Oh, yeah. That it was in my draw that happened because my draw, well, that was radius. Oh, dear. Oh, boy, I hope I don't have to stop this whole thing and figure it out. What did I do different? Now, I'm going to assume that I figure it out here in a second. Because we're gonna press on. I apologize. There's something silly going on here that I did differently, but anyway. It might just be the speed thing that is what I'm about to deal with. Part of it is the fact that we're going really, really fast here. And it's pretty hard to control. And what we want to do is we want to slow it down a little bit. But slowing it down by using the speed isn't always the best way to do it. Let's see, up here, I made my speed, oh, see, whew, I was going even faster. In fact, that's what you want to do, because that's why it's not happening fast enough. Our speed here is only 10, but our block size is 20, and so that's why they're not, that's exactly what the problem is. So if I keep it at speed 20, woo, it works, but I can barely work it, right? So how do I resolve the fact that I need to move 20 for it to look right? There it goes. But I cannot play a game like this, right? And the answer is this draw command here, where we tell it to move. This happens a lot in a second. The computer, CodeSculptor is constantly hitting this loop over and over and over and over again. And it's just too often. So what we're going to do is we're going to create a timer, and instead of moving on every draw, we're going to move on every click of a timer. It's a concept I haven't actually covered in class yet. So down here, we have to create a timer. And this is just another built-in function. In fact, it's I believe it's Simple GUI that create timer. So it's just a function that they put in Simple GUI, and what it will do is it's kind of like another handler. Remember, like the draw happens whenever it decides. The computer says, I want to refresh the screen, and it just draws. Whenever it feels a key being pressed, it does key down. Whenever, so we can kind of add it. Okay, now we want it to do something else, and we want it to do it on a timer. The timer works on milliseconds. So if I said 1,000, then it would click. The timer would like change and tell me something has happened every 1 second. And what's happened? Well, no, not click. That's nice. Like, let's just say the timer ticks every 1,000 seconds. And so this is a function that we're going to use when the timer ticks. But we don't want to just do tick when it moves, or when the function moves. We actually want to just say, hey, move whenever you go. And then do it 1 second? Well, let's take a look at that. Oh, we have to get rid of it out of our draw because we don't want it to do it in our draw. We want to do it in our timer. Oh, and one other thing. Timers don't automatically start unless they're told to start, so we better say timer start down here. So now our frame is starting, which is drawing it, and our timer is starting. So we have to start that manually. Because of this, timer equals, you can actually have multiple timers in a game if you wanted different things to happen at different times. All right, so every second he's moving, and he's moving 20 pixels at a time so that he stays nice and neat, and I just turned. Okay, I think you can get rather bored of that. Obviously 1,000 is not the answer. After some experimentation, 75 milliseconds is a pretty good speed, right? If you want a little faster, you could try 50 or 60. If you want a little slower, you could try 80, 90, or 100. But somewhere around there seems to be the sweet spot for a game playing experience. And honestly, moving on a timer is actually better. I kind of think maybe I should start doing this in all of my games, is moving things on timers instead of being reliant on the draw command. Because this is really its own thing. It shouldn't be, drawing. It shouldn't be moving things. It should just be drawing things. All right, so we've got our timer in there. It's moving well. So we've got our move done, right? We now have a snake that moves. In order to continue this process, it's already been a half hour. All right, that means I'm going to take a break, and you can stop. Up next would be making a snake be able to eat an apple and grow. So it's not that hard. It shouldn't take us very long. I'll be back in just a second.